Hello everyone, welcome back to the MATLAB Simulating Essentials. In this video, we will see the simulation of full wave control type of rectifier. For that, we will use various components present in the library browser and we will try to understand the concept of firing angle. This is the circuit diagram for full wave bridge type of controlled rectifier, and in this video we will see the simulation for resistive type of load, and in the upcoming videos we will see the simulation for RL type of load. Let us start with AC voltage source. Change the peak amplitude to 325 volts and frequency to 50 Hz. Take the thyristor present in the specialized power system library. You can rename this block. I am renaming it as S1 for switch 1. Now arrange this thyristor in the bridge configuration. Do the connections. Connect this anode to cathode. Cathode terminal of both the upper thyristor together and anode terminal of both the lower thyristors together. Now connect this AC voltage source to this bridge configuration. Take series RLC branch. We will consider resistive type of load with resistance of 50 ohms. Rotate this block and connect it across the bridge configuration. Take current measurement block to measure the current across the load side. Take voltage measurement block, connect it across the load and copy this to the supply side. Now take the scope block. We will connect 3 terminals to the scope block. So change the number of input ports of the scope block and the layout. Now connect these signals to the scope block. You can give the name to each signal. Now let us take pulse generator block. You can rename this block as well. Open this block and change the period to 20 milliseconds, or you can write it as 1 by 50 Hz. We will initially consider the firing angle as 0 degree, so no need to change this phase delay, and we will keep this pulse width and amplitude as it is. So in the positive half cycle of the AC supply, this switch S1 and S2 will conduct. So the corresponding time will be from 0 to 10 milliseconds. Whereas in the negative half cycle, this switch S3 and S4 will conduct, and for that corresponding time period will be 10 milliseconds to 20 milliseconds. So pulse for this S1 and S2 will remain the same. But for this S3 and S4, we have to give the phase delay of 10 milliseconds. Because these thyristors are getting triggered after this much delay. So copy this pulse generator and connect it to this fourth thyristor. So phase delay for this S3 and S4 will remain same. Complete the connection of this pulse generator 1 as well. Now take the power guy block. So this block is required for the simulation of the components which are present in this Simscape library. Change the simulation type to discrete. Now save the simulation. Let us consider the stop time as 0.08 seconds and run it. Open the scope block. So this is the output voltage waveform, which is similar to the uncontrolled type of rectifier. As we are using full wave rectifier, so both the half cycles positive as well as negative are getting rectified. Now let us check what happens when we give specific firing angle. So this firing angle is nothing but the instant at which we have to apply this gate trigger to this thyristor so that it will jump into the forward conduction mode. So our one cycle of AC supply is of 360 degrees and corresponding time period is of 20 milliseconds. Now if we want the firing angle delay to be 45 degree, then corresponding phase delay which we have to apply is of 2.5 milliseconds. We have to apply this much phase delay to pair 1, which consists of this thyristor S1 and S2, whereas this thyristor S3 and S4, which makes our second pair, they start conducting after 180 degree. So we have to add 180 degree plus 45 degree. So the phase delay will come out to be 12.5 milliseconds for this thyristor S3 and S4. So let us apply this firing angle or phase delay to this pulse generator blocks. Now save the changes and run the simulation. Open the scope block. So here you can observe the waveforms. When the gate pulse is applied to this first pair in the positive half cycle of the AC supply, this thyristor S1 and S2 gets triggered and they jumps into this forward conduction mode. So here you can observe the output voltage waveform after the phase delay of 2.5 milliseconds or the firing angle of 45 degrees. As soon as this positive cycle ends, this first pair gets turned off, and after this much of delay, this second pair again gets turned on, and here you can observe the corresponding waveform for this output voltage. So this cycle gets repeated. Another thing which you can observe here is the current waveform. So as we are using resistive type of load, this current waveform is in phase with this output voltage waveform. So you can check this waveform of output voltage and current for different firing angles. That's all from this video. Check out the description box for the quiz and do answer them in the comment section. Thank you for watching this video. Like, share and subscribe to the channel Start Scratch, and do check out our other videos to learn similar skills through our bite-sized content.